Hello again, guys. We are now in 13.5 talking about indirect proofs. So a proof involving indirect reasoning is an indirect proof. Now, what do we mean by indirect reasoning? So the most important part of this is that a statement and its negation, or the opposite of the statement, are the only possibilities. So what we do to take care of this is we use our indirect proof to kind of show a contradiction or show something that's not true, because if a possibility leads to a conclusion that contradicts a fact that we know to be true, we can eliminate that possibility and therefore prove something by contradiction. So our indirect proof is as easy as 1, 2, 3. The first thing we do is write out or assume the opposite or negation of what we want to prove. Then through a different method, we will show that this leads to a contradiction, and then when we have that contradiction, that assumption must be false, so what we wanted to prove must be true. So big important thing is the first step of your indirect proof, you assume as true the opposite of what you want to prove. So work through problem 1 on the Pearson module and then come back here for the got it. Our first thing that we're trying to do, writing with an indirect proof, is that triangle BOX is not acute. So we always, to find our first step, want to look at what can I flip around, what can I negate. So if triangle BOX is stated to be not acute, we could negate that by saying that triangle BOX is acute. And in B, since we're told at least one pair of shoes we bought cost more than $25, the negation of that could be that no pairs of shoes we bought cost more than $25. So there we go. So think about your first steps for 1 and 2. We have at least one angle is obtuse, so we could negate the at least one, and we could say that no angles are obtuse. And in number 2, since we're saying the measure of angle 2 is greater than 90, we could negate that by saying the measure of angle 2 is less than or equal to 90. Don't forget that we need that equal in there because this only covers numbers larger than 90. So hopefully you've worked through the next section of the Pearson module. We want to figure out what 2 statements contradict each other. So given these 3 statements, which 2 are contradictory? So we have our triangle is acute, our triangle is scalene, and our triangle is equiangular. So think to yourself, what 2 things could happen at the same time and both be true? And then that should help you figure out what 2 things can't both be true at the same time. And our answer there is that numbers 2 and 3 contradict each other. I cannot have an equiangular triangle that is also scalene. That cannot happen because we know an equiangular triangle would also have all sides that are equal to each other. So in B, we're told that statements 1 and 2 contradict each other, obviously, because we just talked about that. So statement 3 is the negation of statement 1. Where it was scalene is not scalene, so are they equivalent? Are statements 2 and 3 equivalent? Well, the answer down here is no, because if triangle ABC is an isosceles non-equilateral triangle, statement 3 would be true, but statement 2 would not be true, and therefore they are not equivalent. So in 3 and 4, take a moment here to determine what 2 statements in each of these contradict each other. So number 3, we see that statements 2 and 3 are our contradictory ones. It says Val spent $34 for 2 items, and then neither of the 2 items Val bought cost more than $15. Well, if they're both less than $15, there's no way that they could cost $34 combined. In number 4, it's 1 and 2 that contradict each other because we have a right triangle. That's a very important piece of that there. Because 1 could be true in a right triangle, measure of angle A could equal 60. 2 could be true, A could equal C, and then B would be my right angle, but these both could not be true at the same time, so they are contradictory to each other. So we want to use indirect proof in this got it to prove that Y does not equal 6. So again, in an indirect proof, assume the negation of what you want to prove to be true. So here's a nice explanation of what we do. We first assume that Y does equal 6, so then I can plug it in and I can evaluate this expression. We then get 7, or we can then just divide by 7 on both sides as opposed to distributing and creating more work for ourselves. So we get x plus 6 is equal to 10, and therefore I get x is 4. But this is contradictory to a given statement, and if I contradict a given statement, that is not allowed because we know this is true. So because of this contradiction, we can assume y is not equal to 6. So now we're going to fill in the blanks for this proof. So our given is the total membership of the Yoga Club and the Go Green Club is fewer than 20. The Go Green Club has 10 members. So we need to prove that the Yoga Club has fewer than 10 members so that my given can be true with my proof. So we want to assume the negation of what we want to prove first. So if we assume that they have the negation of fewer than would be 10 or more. So we assume that. This means that together the two clubs have, well, what would go here? Well, if Yoga Club, or if Go Green has 10 members, and Yoga Club, we're assuming, has 10 or more, then this would have to be 20 or more members. This contradicts a given information that they combined have fewer than 20, and therefore, since that temporary assumption is false, we can conclude that the Yoga Club has fewer than 10 members. So there are your answers listed out right there. So pause the video and completely fill in the blanks for number 6. Our given is that we have a triangle LMN. We need to prove that triangle LMN has at most one right angle, because we know if it had 2 right angles, it would not be a triangle. So we assume temporarily the negation of my prove statement. So the negation of that would be that triangle LMN has more than one right angle. Go ahead, pause, and fill in the rest of everything. Come back when you're ready for all of the answers. So we already know A got filled in with right angles, but then as we go, that is assume that both angle M and angle M are right angles. And if angle M and N are both right angles, then the sum of them will, or then they both equal 90 degrees. And by our triangle sum theory, that tells me that, L, M, and N must add up to 180, the 3 angles combined. However, when I substitute, I know that angle L we don't know the measure of, but angle M and angle N I already knew the measures of, both being 90. And when I solve this, that tells me that angle L must be equal to 0 degrees. And if we have an angle of 0 degrees, then we do not have a triangle. So that contradicts the statement. So therefore, the temporary assumption is wrong. And we know that triangle LMN can have at most one right angle. So in 7, we're looking for the first step of our proof that quadrilateral ABCD has 4 right angles. So we want to assume the negation of that. So instead of having 4 right angles, if we want to say it does not have 4 right angles, we can say something like at least one angle in the quadrilateral is not a right angle. To contradict that A and B are parallel would mean that A and B are not parallel, which means that not parallel lines always have a point of intersection. So it wanted us to draw a diagram to show this. So we can draw a diagram something just like that. So since this is our prove statement here in number 9, we have to figure out what is my classmate's mistake. They said assume temporarily that angle A is acute, but that's not right. That's not the correct negation statement. So take a second to think about this on your own. Pause the video if you need. Their issue is that A could be acute, but it also has other options. To not be obtuse, well, obtuse just means larger than 90 and less than 180. So my angle could be 90. A right angle, or it could also be straight. It could be that 180 degree angle. So make sure that when you're thinking about negating a statement, you think about all the other possible options for the negation. That is all that I have for you today in the lesson, so please make sure that everything makes sense. Let me know if it does not, and have a wonderful day. See you guys in class.